So let's say we are studying the housing market and our task is to predict the price of a house given its size. This is not that much realistic as the price of a house is affected from many other factors such as its neighborhood, proximity to public transport and other things. However, just for now, let's say size is the only feature we consider. We have a small house that costs $50,000 and a big house that costs $200,000. We want to predict the price of the medium sized over here. How do we do it? To help us out, we have collected more data in the form of these red dots. We can see the price of the house, with respect to its size, goes in a linear upward trend, and we can draw a line that fits this data. The price of the medium-sized house hits this line at around $120,000. This prediction method is known as linear regression. Now let's do a real-world example and see how an actual machine learning project is done. I have found this AMS housing dataset in Kaggle. The dataset contains 79 explanatory variables describing almost every aspect of residential homes in Ames, Iowa. Don't forget that size of the house is just one of these variables, but we will focus on that now. Since this is a non-technical course, I will not show much of coding. I just want to share with you how these operations are done. You will see how simple it is. The code on the screen now is written in Python in Jupyter Notebook environment. In the first cell, I have imported the required libraries and the data. As you can see, the data has many features. In the second cell, I have visualized the data using the size and the price of the house. Since this is a real-life example, the data is not perfectly linear, but we will ignore this fact. Here, now we are splitting our data into training and testing datasets. The training dataset, as the name suggests, is used to train the model. The testing dataset is the sample of data used to provide an unbiased evaluation of the final model fit on the training dataset. The model never sees the test data, and we just use it to evaluate the success of our model. If we visualize both datasets, we can see that entire data is fairly randomly split. In this visualization, red dot represents the test data, while the green ones are the training data. Using the training data, we train our linear regression model. As you can see, it can be done with just 3 lines of code. After the training, our model proposes the blue line, showing the relation for the size and the price of the houses. But what if we didn't like the result? Can we use another algorithm? The answer is yes, of course. There are many more regression algorithms. All we need to do is to change 2 lines of code where we built our model. Let's try XGBoost. XGBoost is an algorithm that has recently been dominating applied machine learning and data science competitions for structured and tabular data. When we apply the change, we get this very strange regression line. Remember, your regression line does not need to be straight. It can be in any shape. And okay, I can apply several different algorithms, but how will I know which of the solutions is better? Is there a way to measure the success of each algorithm? Yes, of course there is. In our next lesson, we will discuss on success metrics for regression algorithms. See you there.